Okay, so we are learning about the first fundamental theorem of calculus. The first fundamental theorem of calculus helps you to be able to integrate with and getting an actual number like we were doing with our rectangles and the trapezoid rule and the Riemann sums, but without all the extra work. So the fundamental theorem of calculus says a theorem if a function f, so that this is just our general function, is continuous on the closed interval, so it goes back to continuity rules, a, b, and f is an antiderivative of f, of little f, on the interval a, b, then when you integrate from a to b, so now we're going to have numbers out front here, before we just had the integration symbols, you get f of b minus f of a. So nothing is really changing other than when we integrate, we will be plugging in these values. So we're no longer going to be attaching c, our constant, because we know what we're looking for. We're looking for a set of values that we have. If you need to pause to finish writing, go ahead and do so. So examples, we're just going to jump right in. Evaluate the following integrals. So the first one says we're integrating from 1 to 2. So from 1 to 2, the equation x squared minus 3. So again, we're going to start by taking the antiderivative. So you're going to start how you've always started. The antiderivative of x squared minus 3 is x cubed over 3 raised to the power and divide by it minus 3x. So, like I said, notice I do not have a plus c on the end. Rather than a plus c, you are going to attach a straight like bar and put the boundaries. These are our boundaries, 1 and 2. So we are going from 1 to 2. Remember, this was A, this was B. Okay, so we are attaching our boundaries to the end because we are going to get an exact number. So if you recall from, I'm going to go back just really quickly. From here, then we take f of b minus f of a. So we got, when we took the antiderivative, there we go, we got x cubed over 3 minus 3x from 1 to 2. So now we're going to plug 2 in to this, and then plug 1 in and subtract them. So there we go. We plug in our b value, which in this case was 2, then we plug in the a value, which in this case was 1, and subtract them from each other. So 2 cubed, which is just from here, over 3 minus 2 minus the quantity 1 cubed over 3 minus 3 times 1. Okay, so we just plugged in what we knew. We subtracted, and we're going to get a value eventually. So then your next step is to simplify. What is 2 cubed? Well, 2 cubed is 2 times 2 times 2, which is 8 over 3. 2 times 3 is 6. 1 cubed is just 1, so it stays 1 over 3 minus 3. So then we just simplify. And then you're going to finish simplifying. I know you guys said it cuts off a little bit in the corner, so you would just finish simplifying these terms, and I did write it, but just in case you can't see it, it is 8 over 3 minus 6 minus 1 over 3 plus 3, because that minus a negative right here turns to a positive, which we get 7 over 3 minus 3, which in turn equals negative 2 over 3. So that is my answer. Negative 2 over 3 is what you get when you integrate from 1 to 2. Okay, so when you integrate from 1 to 2, x squared minus 3, you get negative 2 over 3. So now we are getting actual answers rather than just plus c, plus a variable at the end. So we're getting the whole answer. We're plugging back in. Let's try another one. B, integrate 3 times radical x from 1 to 4. So again, remember, you're going to start with taking the antiderivative. And again, as usual, if you want to stop and pause and try it, which I highly recommend, you can do so, and then work through the rest of it. So when you take the antiderivative, we get 2x to the 3 over 2 from 1 to 4. So it was x to the 1/2, which is x to the 3/2 over 3 over 2, which turns into, when we factor and cancel everything out, we're just left with 2x to the 3/2. So remember, the 4 is my b value, the 1 is my a, so I'm going to take that f of b minus f of a again. So there I go. 2 times the quantity 4 to the 3 halves minus 2 times the quantity 1 to the 3 halves. Notice I've just repeated this function right here that I got twice. Okay, simplify. I get 16 minus 2 because 4 to the 3 halves is the same as 8 times 2. 4 to the 3 halves is 8, and then we multiply by 2. 1 to the 3 halves is 1 multiplied by 2. So my answer is 14. And another example with trig. Now don't let this scare you. I know it's trig, but it's really no different. So again, we're just taking the integral of secant squared x. So whose derivative is secant squared x? Well, it's tangent x. So then we have to solve for tangent at pi over 4 and at 0. So we get tangent of pi over 4 minus tangent of 0. At pi over 4, tangent is 1. At 0, it is 0 because remember it's y over x. And at 0, y is 0 and x is 1. 0 over 1 is 0. So the tangent of that, or tangent of pi over 4 minus tangent of 0 is just 1. So the antiderivative of secant squared from 0 to pi over 4 is 1. So again, we are finding values. Okay, there's some try problems on this page. I'm going to click ahead to the answers in a second. So go ahead and pause it so you can work them out to the best of your ability. I did not go through steps, but I did put the answers, so even if you didn't get it, you can hopefully get it when you redo it. And number 4 is the exact same as the example I just did. Sorry, I just noticed that. So really 1, 2, and 3. Go ahead and try. And here are the answers. So 38 over 3, 88 over 3, 1, and 1. Okay. So evaluating regions bounded by a curve, which is what we have been doing. However, this time it's going to give you more of an equation. It's not going to set up the integral for you. So this one is, it is the most challenging one we will do, so just stay with me. The other ones are more straightforward. So it says evaluate the absolute value of 2x minus 1 dx from 0 to 2. The absolute value. So again, what type of function is this? It's an absolute value function. So when we integrate it, we have to follow different rules than what we normally would. So let's take a look at the graph of this function. So notice the graph, it's going negative right here. This line is a negative line. It comes to a point. So it's not a curve. It's not like a sine curve or an x squared curve. It's coming to a point. It's two lines that meet at a point and make a V. So this line, we essentially need to look at the equation of this line and the equation of this line, which frankly they give to us right here. Both are it's a form of the 2x minus 1. So to figure out that, what we need to do, so again, notice the two lines, one is positive right here, one is negative right here. We need to determine where it changes direction. Okay, at what point down here is it changing direction? And we need to set the positive of the equation, so 2x minus 1, just the general equation, equal to 0, and then the negative of that equation. So we're going to negate that whole equation in order to determine where it's changing direction. We should get the same value, but then after we do that, we're going to have to break it up into two different integrals. So let's do the positive one first. So 2x minus 1 equals 0. We would add 1, divide by 2. We get x is greater than or equal to 1/2. So at x is greater than or equal to 1/2, as you can see in the graph, it goes positive. Okay, it's a positive line from there on out. What I mean when the negative, so notice I have this negative out front, so I'm negating the whole thing because this line is just the negative of this line because it's absolute value. So we set it equal to 0 still, but instead, it's a negative of the equation, and we get the same number. This is equal to 0 when x is 1/2. However, it's when x is less than 1/2 because everything to this side. So we, are looking at the area right here from 0 to 1/2. I don't know if you can see my arrow, but I hope you can. And then from 1/2 over to 2, this area. But we're going to need two different integrals to do that. So we're going to use these two equations and this x value 1/2 to split into two integrals. And I'll show you what I mean on the next page. As always, remember you can pause, go back, whatever you need to do. Okay, so here's our integral, here's our bigger graph. So this is going to be one part. That is our negative part. Okay, that's right here. From 0 to 1/2, we're using the negative line, essentially. This line right here. Okay, from 1/2 to 2, we're using the positive line. So right here. Okay, and then we're going to solve it the same way. We're going to integrate, and I get negative x squared, so I distributed this negative sign essentially. The 2's cancel, plus x from 0 to 1/2, plus x squared, because there's no negative. Oh, that should be a minus x. Okay, this right here should be a minus x. I will fix that and redo the answer to this problem. I knew I wasn't getting the right answer. That's why. So right here it should be a minus x, not a plus x. I will fix that. I believe your answer should be then 5/2. The rest of the work following this for this problem is not going to match up, but I will fix it and then post it to Schoology so you have the correct answer. So again, this should be a minus x right here. That should be minus x because of this is minus up here. So minus, minus, I did not do that. I will fix it. None of that work will be, or most of that work will not be right because of this part over here. I think once you do that, you get your answer to be 5/2. So let me correct it and I'll repost it. Not the video, but just the PowerPoint on Schoology. You can go back and look at it. Okay. No. Okay, there we go. Oops. Okay, find the area of the region bounded by the graph, y equals, so it's giving us a function, the x-axis, which doesn't really matter to us because at this point it's above the x-axis, or from 0 to 2, your graph is above the x-axis. And if it's not, it's stopping there. So anyways, this is just saying you're taking the integral of this function right here, 2x squared minus 3x plus 2, from 0 to 2, as you can see by the integration right here. So I'm just taking, when it phrases it like this, it is no different. You're just taking the integral of this function from 0 to 2, from x equals 0, because remember these values we plug in for x. So you integrate, and again, if you want to try this, you can. I am running out of time, which is why I'm going quickly now. So you integrate, and you get 2x cubed over 3 minus 3x squared over 2 plus 2x. We're going to plug 2 in to everything, and then subtract it with 0 plugged in. Well, this whole right side is just going to give us 0, because 0 times 0, anything is 0. 0 plus 0 plus 0 is just 0. So we really are just left with this part, which simplifies to 2 cubed is 8, so 2 times 8 over 3 minus 2 squared is 4, so 3 times 4 over 2 plus 4, which is 2 times 8 is 16 over 3 minus 3 times 4 over 2, 16 over 3 minus 2, which equals 10 over 3. So really, again, this is no different than what we were doing before, it's just phrasing it differently. And the last example, again, you're going to set up your integral from 1 to 4 this time, based on what it says. Find the area region bounded by the graph of f of x equals 3x squared minus 2x, the x-axis, x equals 1, and x equals 4. Integrate, so this one we get x cubed minus x squared, plug 4 in, then plug 1 in. So 4 cubed minus 4 squared minus 1 cubed minus 1 squared. Remember that you do need parentheses because this will affect what you get. 1 minus 1 is just 0, so that's going away. 4 cubed is 64, 4 squared is 16. We are left with 48. Okay, remember your homework is in the Princeton Review. Let me see if I can find. Oh yeah. Page, practice set 22. This right here. I don't know if you can see that. So practice set 22, it's page 174. You need to complete all. It's 11 problems, it looks like. Yeah, 11 problems. And it's a combination of all of these. And I will fix that one problem that is on here. Back a few slides, the absolute value one. I will fix the work on it. Okay, have a great weekend. Email me or message me on Schoology if you have any questions. Thank you. Bye.